Hey, this is Michael, and today I'm going to show you how to do a few math problems. Our first problem is we have to select all the expressions that are equivalent to this. So we took that equation and we wrote it out over here. Well, we're going to factor out the 3x to the third, and that is going to give us this. So now we are having to find the equations that are equal to this. Our first equation is 3x to the third times x minus y to the second, and that is going to be the same as 3x to the third times x minus y times x minus y. Well, now we have to use FOIL, which stands for first, outer, inner, and last. So we are going to use the first, which is going to be our x, both x's. Then we're going to use our outers, which is going to be our x and our y. We're then going to use the inners, which is our y and our x. Then we are going to use our last, which is going to be our two y's. And that gives us this. So now we have to distribute 3x to the third all the way across the equation. But we can't forget to add our exponents. So the 3x to the third times our x squared would be 3x to the fifth, because we had to add our exponents. And that gives us this. Therefore, this does match our initial equation. This one, we just have to distribute. So we are going to distribute the 3x to the third across the equation, and that is going to give us this. Therefore, this does match our initial equation. This one is similar to our first equation. We're going to set it up like we're going to use FOIL. Then we're going to distribute the 3x to the third, and that is going to give us this. But as you can see, this does not, it is not equivalent to our initial equation, because this is a plus and this is a minus. So for this equation, it is already set up to be used as FOIL. And then after we use the FOIL, we get this. Then we have to distribute the 3x to the third, which is then going to give us this, which is not equal to our initial equation. So this one is similar to our last one. It is also already set up for FOIL. So once you plug the FOIL, you're going to get this. Then we must distribute the 3x to the third, which is then going to give us this, which is equivalent to our initial equation. So for our second problem, we have trying to get everything to equal this. So we have 16 times 2 to the n minus 3. Well, first we have to change it to use the power rule, which we are going to break the 16 down to 2 times 2 times 2 times 2, which is equal to 2 to the fourth power. So we have 2 to the fourth times 2 times n minus 3, or to the n minus 3. Then we are going to use the power rule and add the exponents, which is our 4n minus 3, which is going to be 4 plus n minus 3 equals n plus 1, which is going to give us 2 to the n plus 1, which we are trying to get every equation equal to. So for our first equation, we have 2 to the 4n minus 12 equals 2 to the 4n minus 12. Therefore, the answer is no. It is not equivalent to the initial problem. For our second equation, we have 2 to the 4n minus 3 is equal to 2 to the 4n minus 3. So therefore, the answer is no. It is not equivalent to our initial equation. For our third equation, we have 2 to the n plus 1 equals 2 to the n plus 1. Therefore, this equation is equivalent. For this equation, we have 8 times 2 to the n minus 1. We have to use the power rule, which is going to give us 2 to the third times 2 to the n minus 1. Then we have to add our exponents, and that is going to give us 2 to the n plus 2, 2 to the n plus 2. So the answer is no, this is not equivalent. So on this equation, when we use the power rule and we add our exponents, it is going to give us 2 to the n plus 1, which is equivalent. Have a great weekend.